All right, resolved. I have updated the bitrate for the recommended resolution, or the resolution I'm using. So back to what I was doing here. Apparently, when you just call new on something, it's using a default constructor, which doesn't exist. The parameter list constructor, which you cannot seem to implement yourself. So annoying. Oh, I had to think of a fun way to go about this, I guess. And you can't set default values in structures. I mean, I could change it to a class, I guess. That would cause some allocations. I almost said allocasias. I have plants on the mind. Alocasia is a type of plant. Annoying. You know what? I'm just gonna make it a class. I shouldn't break anybody's project at all. Becoming a class. I'm just gonna set the default stuff. Read permission dot observers equals 0.1f. This should actually be the values of the server manager for the defaults. Let me check that, because that's current bitrate 0 is recommended. What? It says the audio bitrate is 0. What did I do? And well, now I need to make sure my audio is working again. All I did was change the video bitrate, but apparently no, it's just mad. All right, so it's not actually 0. It's working fine. I can hear the audio. It's working fine. YouTube apparently is just giving me a really hard time right now. Seems to be working though. So we're going to ignore that and continue onward. All right, so the server manager actually has a default setting for that. And thought I implemented that. No references. Oh my god. This is really awkward. I apparently put in a feature and did not implement said feature. Like, I just partially implemented it. This is wrong too. This must have been like a work in progress that never got finished. That is not good looking on me. But I'm gonna fix that right now. So let's do that. And yeah, whoops. All right, so we're gonna change this slightly. I think we can still use a struct. We're gonna still go to structure. We don't need the allocation. We can do this. For that, we don't need that. We can do this, and we're gonna do an nb dot server manager dot get sync type rate. We'll keep it debug there. Okay. Oh no! What? Oh, why? That should be set. Oh, it's not set because it's a network behavior. Yes. Okay, so this isn't necessarily a problem. need to go to this though right here. And this is where I need to actually set it. The network behavior is set in the initialize early, but it's not actually initialized on the network at that point. So this is where it needs to be set. This is where it's being initialized on the network, or at least with the network manager. Let's go ahead and try that. Woo! Okay, that's working. Now I can remove all this debug. Okay, great. I kind of think that when you're actually setting it in the constructor of like the network behavior, I wonder if it's actually setting it there or not. Anyway, it doesn't matter. The issue has been resolved, so let me go ahead and test that out now. Oh. Okay, so the interpolation is still not working. It should be updating every 100 milliseconds. So we should see it. The tick rate is 2, by the way, so that's updating every 500 milliseconds. Yes, tick rate 2. So this should be increasing in intervals of roughly 100 milliseconds, which it's, well, the actual value is 0 there, so that's why. This is what we want to look at. Oh, it is working. Okay. There's just, I have so much debug in there that it's hard to follow, but it looks like it is working. Let's go ahead and check that out real quick without all that extra debug. Hey everybody, Hexagon, Emmanuel, welcome. No, it's kind of working. Like, let me get rid of these other errors real quick. These are just other things that are debugged, just make sure it's working right. Get rid of that. And so it's still, something's not right because the value is set to should be printing way more often. Like, this seems right, like it wants to work here and here, but it's not. I wonder if my frame rate is being capped or something and it's actually working right. I don't think it is, but check it out, see what happens. Remove that print cap. Gonna spam my console a bit. Okay, so I know what's going on. It actually is working properly. The reason it's interpolating on the same value, even though, well, the reason I should say it's starting to do this and then just seems to kind of display the same value over and over, is because the interval for the sync bar is 100 milliseconds, but the send rate is 500. So it's ending the interpolation early. So the solution for that is quite simple, actually. I just need to go to the server manager. It's actually two solutions. One is to confirm that what's happening is happening by making the sync type rate match the tick rate, in which case this should increase steadily until the value changes and whatnot. Second way I'll get to in a second. It looks like it's working now. Great. So let's go up to where it says 2.5. Looks like it's just about there. Hits 2.5 and keeps going. Perfect. That is exactly what I wanted. All right, so the other solution, which is probably the more proper solution, is keep this send rate at 100 milliseconds as default. And because we don't want people to have to remember to like do this and this. I know it's not very likely that the tick rate's going to be higher than the send rate, but realistically, I should be prepared for that, of course. So let's just go here and do float send rate equals math f dot max server manager dot get sync type rate, or network manager dot transport manager dot tick, sorry, time manager dot tick delta. Just got to convert this to a float. That way you'll use whichever is greater. So if the send rate is greater than the tick rate, it's going to lerp over the send rate. Otherwise, it's going to lerp over the tick rate. Hit play, test it out. Looks like it's working. Yep. Perfect. All right. So I was talking to Kobe. I don't know how he says his name. He's actually given me some suggestions to work on this. We're trying to think of the best way to simplify the process. I'm gonna give him the link because I don't think he knows I'm streaming. So I'm gonna let him watch as I steal his code. No, I'm not stealing his code. I think he won't mind if I use it. I'm going to actually ask before I do, though, of course. Let me just get him the link for my stream here. The YouTube Studio. I'm doing stuff on the other screen. Sorry if you just looks like I'm doing nothing right now. Content live. Okay, where is the URL? Get shareable link. Here we go. All right, so I'm gonna try what he suggested. So I'm gonna take this here, this code bit you can't see, and paste it into SyncVar. This is what we're kind of talking about too. How it's. I guess I don't need to do it here. I could do it in the right here. This is where we're talking about that you can't see. Basically, trying to do it in the most efficient way possible. So right now, how it's being done is if we go to interpolated sync vars, this is internal or an internal file, I guess, but you can access these. There's different ones for each type, and ignore the iCustom sync. There's different ones for each type that there's interpolation, and it overrides a method in SyncVar. So the method it overrides is this one. And that way, one, we can basically throw if a type's not supported easily enough, and two, we can override it easily enough with these, and it's it's efficient. There's no checks, there's like no casting or anything like. Well, I mean, there's some casting like that, but you get the idea. But yeah, so that's how it is currently. But this is going to be a little bit of a pain in the butt because you have to basically make a type for every one you want to interpolate, and it also messes with CodeGen a little bit, which is annoying. Oh, sorry, one second. My girlfriend was messaging me from work. Okay. We're gonna go back up, do this, and lost my place. We're up here somewhere. Great. All right, so we're still gonna use the same thing as this here, the whole different stuff. So this is what he's suggesting. He's basically saying to put a switch on what the type T is. Was that off? Yeah, it doesn't seem to like this. I know he just basically... Yeah. Yeah, I don't think that's gonna work. It was a good try though. He's also using types of, I mean, the switch statement has obviously been around for a really long time, but he's using types from a higher level of C# and it might not work in the Unity version. That's a strong possibility. But the built-in ones are working. The only issue is that it's required to use the iCustom type. Which I guess it kind of is a custom type. I need to check a few things. Basically, the custom type flag indicates a few things, actually. It indicates, it changes internally how it's initialized. And a lot of this is old, like, Cogent stuff that's not entirely valid anymore. But it changes how it's initialized, and also it pulls this method here to check the type so that it can create a serializer for it. Because if you just have like a float sync var, for example, and it doesn't actually have a generic, so it's just kind of like this, it doesn't know what type you want to synchronize from this. So that's the whole point of this. And this is something that's built into Fishnet, so you can make your own custom sync types. All right. So it says, if I look at the code gen, I'm actually just going to do this and this. And let's go back here. I'm gonna get an error. Blah, 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 does not implement iCustom sync. That's what I was just talking about, by the way. Let's see if I can find that. I don't know why that's not coming up. Does not implement. Oh, that's why. Okay, so does not implement this. I don't know if that's true anymore. I know this exists. I think this needs to be if is sync object, and so only sync object, only sync object is kind of like an internal thing. It used to be a little different way in the past. Now it's more internal. Basically, sync objects are custom types that can't be unreliable per se. And that's kind of the only restriction. If it's a sync object type, then it has to send reliably. Sync vars do not have to send reliable. I think that's the only thing sync object is actually used for now. Uh-oh, I broke it. I broke it good. All right, let's see what I did. I have a feeling it's, let's just see. Value cannot be null. Module definition. Sync type processor. Line. This is why I hate Sessel or whatever it's called. It is not great to debug. All right. All right. So get. Got it. So what it's basically trying to do is it's trying to get the type that needs to be serialized, and I should Oh yeah, so it's looking for that method that I had earlier, this one, and it doesn't exist. So I'll go back to here. If user is returning null, then they're indicating a built-in serializer already exists. Well, that makes things a little bit easier, I guess. I mean, I guess I don't really have a reason to not implement the iCustoms interface. So let me just go ahead and undo that. Well, no, I do have a reason because no, I don't. I was thinking I did because this check is going to prevent it from being unreliable, but this doesn't actually do that. This is just for getting the serializer, making sure it exists, basically. So I'm gonna just do null, and I'm gonna put a comment. Type has a built-in serializer, so null can be returned. When no built-in serializer exists for type, the you know what? I just realized, what if I have a custom type and it's not something that has a serializer? I wonder if overriding syncvar or basically inheriting it is going to break that. But then again, I guess that's the point of, play it safe. This works. There's some reasons that it might or might not break, and I know it kind of sounds like I'm rambling because I am, I guess. But Cogen's a pain in the butt, and we're actually dropping Cecil to a degree. We're improving it with replacing it with newer technology. Is going to be way better. They're already hard to convert float to. Oh, so they're saying I could try taking the code snippet. And he's basically saying this. Oh, dude, that was a good try. That was a good try. Oh, this is in sync base. I mean, I don't think it's gonna matter, but we'll try here. Yeah. That sucks. Like I get what he's trying to do and it makes sense. But I guess this just isn't going to let us do it. This would be ideal though, so we could basically do it in the method and make things really cool, but yeah. All right, so I need to go ahead and put this. I am a little concerned of that. I don't think this is going to block out using unreliable, because the check for iCustom sync is done after it checks if it inherits from syncvar. So I should be safe. Let's see. .custom. Oops, wrong one. Go here. Custom. Dot. Okay. So here's where I get the sync type, and yeah. So it's going to default to syncvar first. That's going to be the first one it checks. Thank you, Billy Wonka. Willy Wonka. Yeah, thanks for checking into that. So let's see. Now I just need to go back to here. No, sorry, back to here. And I need to implement the interfaces. Type of double. I really could just return null, because these already have built-in serializers, but I don't want somebody to look at this and be like, oh, well, he put in null, so I can use my custom type of structure or whatever and just put null. No, because if you do that, it might not generate a serializer for your type, and that's no bueno. I really cannot wait until I no longer have to use Cecil. It's just such a headache. I'm just gonna type vector and copy and then do 2. I probably should need ones for like int as well. Whatever, I'll do that too. This, copy, paste. Add int. Oh, is there no vector for int? Huh. I guess there's no vector for int. Paste. There's no lerp either. Stupid. Oh my gosh. Of course there's no lerp. That would make too much sense. Okay. And I just finished my coffee. So let's see. Guess I could do int x equals math lerp previous dot x current dot x percent. Convert that. This is so stupid. Why is there no built-in lerp? You would think there would be. Cool, okay. Is there a vector 2 int? Yes, there is. Why the hate for vector 4? Or why is there no vector 4 int? What the heck? I'm gonna check just to make sure I didn't like make a typo or something. Vector 4. Oh, there's no vector 4 int. Huh. Okay then. So let's see. The vector 2. Oh, also gotta fix this. That was almost dumb. The old copy and pasta got me. Okay. Again, you can make your own just the same. Like I'm just including hard coded types just for everybody, but you can definitely make your own. There's no limitation to that. We'll add more in, I'm sure, as they're requested. All right, so what's going on here is you have to call interpolated value instead of just value, and you'll notice this is a method. So the reason for that is, and this is, so you're going to notice that right now I am setting only if the frame has ticked. So I'm setting the value every 500 milliseconds, but I'm printing every single frame. I'm not going to print every single frame because that's probably my poor computer. Okay, I'm going to print every 100 milliseconds just so we can see it's working, but also make sure, there we go. So anyway, it's updating every 500 milliseconds to the actual sync var, but it's printing every 100 milliseconds. But you'll see this update every frame thing. So what if this were actually adding in, like you're setting a normal delta, like for the frame delta instead of tick delta. So just to show you an example, float delta equals update every frame. If we're doing it the frame, we're going to increase by the delta frame. Otherwise, we're going to increase by the tick delta, because we're again using the frame ticked. The actual value that's being added on doesn't matter. This is just for testing. But this is why I'm going to show you where I expect things to break. Oh, that's interesting. I thought it was going to always show me the previous value or the next value, but it's not. Okay, so here we go. Here's where this is where things get interesting. So you can see that it is showing a value of 0.049 where the actual value is 5. What it's doing basically is it's taking time passed from the previous value to the new value and getting the percent of time passed used in the lerp, and it just coincidentally the time passed was nearly the full tick. I'm trying to think of how to explain it. It's kind of hard to really. It could be because I'm printing every other or every 100 milliseconds too. I'm not quite sure how to explain what's going on. Sorry for that, but I expect it to break and it's not breaking, so that's kind of annoying. Go back up. Okay. That's no. I forgot to check the box. That's what it is. Update every frame. I forgot to check the box. Okay, there we go. All right, so now let's look at it. So you can see this is always going to be like behind one, and it's because it was just set. I have a feeling if I actually increase the tick rate to something like 30, that might get a bit uglier. Take a look. Oh, no, it's still only one behind. Interesting. Very interesting. So I was expecting it to be much further behind because the syn rate is 100 milliseconds and the tick rate is what is 30? Probably like 33 milliseconds roughly. So I would think it would be, this actually could be right, because it could be basically the difference between that halfway through the interpolation. So that makes sense. That might actually make sense. But basically the idea is that you can toggle this here where you can say use current value true, and it should give you the current value. So let me show you an example of where that might use that. Let's check it out. Yeah, so now it's actually using the current value. So for an example, let's say base.hasAuthority. Excuse me. Or let's say it's going to change depending on your usage, but so let's say if the server is the one setting the value, we're going to use the current value, but that's only if you're like setting an update. If we set it outside update, it's going to update every only every tick, and the values returned is going to be the last tick without any interpolation. Just the fact that I can't really properly explain this kind of tells me that I need to make it more simple. It's just not really, you know. So let's see. I also just realized this might not work for client. That bit's not tested yet. Like client only is not yet tested. Let's see. Void update values. Void update values. It helps if I'm in the right class. All right. If network initialize, we're going to update the value, and last value is becomes set, and the update time becomes the current time. So basically, whenever you get the interpolation, it takes the current time subtracted from the time it was updated and does an inverse lerp on that. So might be easier if I show you. So here we go. The difference is, like I said, current time minus last update time. Then we're going to inverse lerp that over the send rate. Basically, if enough time has passed to where the send rate has been met, then we know it should be 100% of the lerp. It's actually, the time value is calculated per syncvar. It doesn't need to really. So the thing is with syncvars is you set them as an interval. The default's like 100 milliseconds. Internally, it uses ticks. It converts that to ticks. But you know, setting your interval to 1 tick, 5 ticks, 10 ticks, whatever, it doesn't feel as natural for their use case. So it's basically set at an interval instead that people are familiar with, and then it's converted to ticks. But since we still have the interval, we can just see how much time has passed since when it was set versus current time, and that's our lerp percent. And that's basically what's going on here. Okay, give me 1 second. I'm just checking something out. Just another Kobe suggested another approach, which I did consider, but he realized it as well, of course. But the second approach requires boxing, which is also bad. We won't be doing that. Yeah, so basically, this doesn't have to be something in the documentation, I suppose, because you might, if you're setting the value, you might want to use the current value you just set, or you might want to use the interpolated value. It just depends if you're setting it on tick or if you're not setting it on tick. And I can't like do this internally. Like I could check if the value was set on a tick. That's no problem. I can definitely do that. So like when this is called where it's being set, like okay, well if that's on tick, then they're probably setting it only every tick and thus should use interpolation. But there's going to be frames where it is on tick and frames where it's not on tick if they are setting every frame, so that's not going to fly. So yeah, I guess this works. Like it's just one of those things I'm going to have to document because there's no way like I can force a mechanic, but then there's going to be somebody that's like, I want to do this, and I can't blame. Like I understand, I get that there's different use cases. So what might make more sense is something like this in user code. Can update sync vars in real time. This is a really long method. We're gonna say if base dot. No, we don't want to do. Well, yes. Okay, we're gonna say base dot has authority and base dot is server initialized. Well, no, because has authority could be false if you're the server. We're just gonna do if base is server initialized. We're just gonna return that. Basically, this says that only the server can update the sync vars in update. Everybody else is going to use the interpolation otherwise. So let's say if base dot is server initialize, or let's just can't update sync vars in real time. Why not? This should work fine. And then same thing. This is just an example. Like your code's going to depend, you know. It needs to be documented. That's basically what it is. Documentation has to be read. It has to be clear. You have to read it. All right. That's working. Now let's load up the second client. I'm going to first set the tick rate to 2. And I'm going to open the second client. Make sure my vertical sync is on so I'm not killing my video card here. It is. Okay. This is another feature that coming in the release that a lot of people are asking for, the network transform teleport. Kind of, I don't think it's 100% necessary, but I know a lot of people prefer that approach, so I added it in. Client. Okay. I can't see the object. I should be able to see the object. So do I have an observer manager? I do. There's no player. That. There we go. All right. So let's go ahead and check the log. Looks like it's working. All right. So interpolated value is this doesn't seem right. It should be interpolating over the sync interval, not. Oh, it's interpolating over the tick delta or interval. That's right, whichever is larger. I just don't think it's increasing that much because I'm going to put this back in so it makes the code a little bit easier to follow. All right, so now it should only be setting it every, let me untick this. Should only be setting it every tick, which is every 500 milliseconds. Yeah. And the interpolation appears to be broken because the code is basically saying it's being updated in real time. So it's returning the current result rather than the interpolated result. So that's why I said this is a great example why I said it depends on your use. All right, got some debug going. Let's see. Yeah, that looks good. That is working. Perfect. All right, so interpolated sync vars appear to be working. Great, 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 great. All right. The other thing is that I need some kind of interpolation between. I don't think I'm going to be able to get this particular feature in that I'm about to mention. It'd be nice to have interpolation on prediction types too. Like if you have, a float or whatever using using prediction, and the value changes from 1 to 2, and let's say your update interval is 100 milliseconds, it should, if you call, basically the same thing we're doing here, where you can print the interpolated value of said value, it should just do it over whatever the tick delta is or send rate. But I don't think I'm going to be able to get that in this release. Just kind of pondering how I might make that simple. I mean, somebody could use. I mean, I could make like an interpolated type structure like the other ones, but this doesn't seem like it's the easy way to do it. I think probably the best way potentially is I considered just like passing in like just calling a method that basically pulls the field as an interpolated value and does some magic internally, but that doesn't seem like that would be very efficient either. So something needs to be done about it, but I'm not 100% sure yet how I would go about doing that. And it's not on the agenda for this release anyway. It will be eventually, though. Just needs to be thought about. Also, something else that I would like to do is move away from my script. Move away from the current way that we have reconcile data and whatnot, and replication data. So let me just show you. And this is kind of basically how I think how I don't actually, I've never actually used Fusion besides like running one of their demo projects, just to kind of see how it compared like the performance and whatnot. But I've never actually looked at how to use their code. I just opened it up and ran it under different conditions. But as I was saying, I think this is roughly how Fusion does it from what I've seen people comment and whatnot. So I'm going to go to my prediction demos, just open up the script here. This doesn't exist in the actual project. These are kind of a work in progress. Struct tlerp start in. Oh yeah, I considered that too. Going the interface route. I'm reading chat, and I don't remember what it was, but that didn't work for me. I think I ran into the same situation where you basically have to you're stuck format like converting T one way or another. All right, so as I was saying though, so right now this is like a replicate data, and so you got, this doesn't matter, just ignore that. So you have this here as your types that's going to be replicated. So instead of like making it like this, I just simply wanted to make it so you could do things. You got jump, horizontal, and vertical like this. This isn't like, I'm not trying to, oh, there's already a jump. I'm not trying to like pretend like I invented this or anything. I'm sure tons of frameworks have already done it this way. Basically like this. And what would happen is whenever you modify that variable, normally it's going to send it over the network, and it's going to roll back these variables as well when you are doing a reconcile. basically you just don't use the reconciled data anymore. So let's say if this was the case, this is all log test code, so kind of disregard that. So let's say that this is the new change. You don't need this. Probably still going to use the state because the state's really helpful. It's a bit more low level state in the channel, but super helpful if you want to do like future prediction and try to guess inputs that haven't been arrived yet. So instead of doing all this, you're just going to do like that. So it's going to feel more natural. At least that's the goal behind it all. Is just make it feel more natural. It's not really like doing anything different under the hood. It's still sending the changed values. It's just you're, instead of referencing them in the struct, you're referencing them as they are, and it might just feel, might make more sense. I don't know like how others feel about this, but that's the idea. As far as reconciling goes, that's a little tricky. Now I can reconcile these values because they're value types or whatnot. I be like, oh yeah, well, the Boolean jump at this state was so and so value. I can send that back, no problem. But what if you also want to reconcile positions and whatnot, velocities, which you're going to want to do? If you don't reconcile those, you're going to have a desync, especially if you're using physics, because physics is not deterministic. Okay, so let's say reconcile new. Get rid of this. And let's say we're not using the data in this case. So I could easily just do, okay, well, I don't have to actually do jump equals anything, because I could just set this automatically internally. I can make the Cogent do that pretty easily. But let's say I do want to do transform.position equals, where is it? Let's say this value, which I can't access because it's not there anymore. But this is what I'm saying, is if we dropped off the reconcile data, you have to somehow be able to set this. So what that might look like is something like this. So it might look something like this, where what's going to happen is it's going to read that this is the reconciled variable, and it's going to send that in the reconcile. And then here you could just do rec position. This obviously is not going to work because this is going to forward this here. That was a bad example. So, or rather, it won't work that way, I guess is what I'm saying. Yeah. So it's just going to forward the same position. But you get the idea. I don't know if there's actually like a great way to do that. And I could just send the transform and the reconcile message and like do it internally so you don't see it, like that with rigid bodies. But and that's probably how a lot of them do that already. But there's a lot of stuff that might not need to be reconciled, or that might have to be reconciled as well, that I'm not going to think of sending, like drag levels, mass, things like that. I could definitely check for those changes. I could, have a delta writer only send what's what needs to be changed or what has changed, but a lot of it could be overkill. Might not have to do that to begin with, and that's kind of why the reconcile is a tough like spot to fit, and you might have to actually make a reconcile data. So yeah, I don't know 100% yet how that would work with the new format. I think you'd probably have to just do this and go up here, and this could technically just be a float like this. And just have this one as prediction variable. Since this is a value type, it can be easily reconciled and set as a replicate. When I say value type, I mean it's something that I can know how you want to do it, like for sure. But instead of for like other types and stuff like position, you'd probably have to format that and just use the old method. I'm open to ideas, of course, but like you still might have to do that for certain ones that are a little too situational to guess. Yeah. I'm not really seeing any other ways, besides this, but not the end of the world, I suppose. And it certainly saves a bit of work, so you don't have to you don't have to do vertical velocity equals RD. That doesn't exist, but like that, for example. So it saves time, I guess, for you and complexity, and maybe down the road there'll be a way to actually do it in a more sensible fashion. Yeah, this is what I would like to move towards eventually, perhaps. Just not 100% sure yet because kind of, I don't know. I like this because it gives you basically a more natural way to code, but it does definitely add in complexities to the internal system. It's probably not as efficient, also, and there could be other gotchas as well. So let's say if someone did this prediction variable public float health. So let's say if this were exposed and I accessed this from another script and modified it, even though this has a prediction variable attribute, it would now have to actually automatically be sent and reconciled, and that means you'd have to set up a replicate, a reconcile, and call it. So it's needless to say would require a lot of work. I mean, I don't know if it'd take a lot of work, but it would take a good amount of work in testing to make sure it's working right. So when I say a lot of work, I mean to make sure it's functioning as intended. And that's definitely for sure. But that is also another benefit of the system, though. You don't actually technically need the replicate state. Like all this, you don't technically need that. You could just as easily run that code and like update or tick or whatever, doesn't really matter. But you would lose access to primarily the replicate state. And like I said, that is like a low level feature, but it is super handy if you want to predict future states. So I don't know if I'm gonna actually end up going this route. Honestly, I feel like it puts a huge limitation on things, and adds a bit of complexity. I don't know if I'd say limitation. It doesn't really put any limitations, I suppose, but it definitely adds a ton of complexity. So I think probably what I'm going to do is just make it so that this is easier to like use and understand. I think that's primarily where people get stuck. There it is. But yeah, this isn't even needed. And I actually saw a really cool system to where you could just basically Bobsy actually showed me this. I can't post any codes because it's probably, I mean, it's not really under an NDA, but I'm not going to share code that was shared with me in private. But basically, the idea is you just have a master script that calls the methods on all the other scripts, and that way you control the order when things are replicated and whatnot. So, pretty simple, but it organized it in a very elegant way. I liked it. Okay, making a racing game and considering using fishnet for online suitable. I mean, you can use it for a racing game. I assume you're going to use prediction. Yeah, I mean, you could do it. The only thing is that a lot, and this is kind of just with any system that's going to use prediction. Again, assuming you're using prediction. If not, you're not using prediction, then things got a lot more simple, but you open it up to cheaters potentially. But anyway, so if you're making a racing game, you're probably using a physics controller because that's some reason when everybody uses. It's, I guess, because it kind of does the work for you in a lot of cases, but physics are expensive, and every physics controller I've seen for a racing game is expensive because it uses wheel colliders and a bunch of different complexities around the physics system. So when you do that, you have to keep in mind that the local client's going to have to roll back occasionally for corrections, and when they do that, you're going to have to reset the state on those rigid bodies, which we actually have some built-in stuff for that to make that really easy. But more so, you're going to have to roll back the state to however many ticks the client latency is. So let's say if they are behind 100 milliseconds, and that's just, we'll just say 7 ticks in this case, it's going to have to simulate on the physics 7 times after reconciling, just to make the corrections needed. And that could cost you client-side performance. And some machines can't handle that. I mean, 7 ticks isn't that bad, actually, but just something to keep in mind. We are actually adding in another feature, though, next release, that is going to make it so you don't have to reconcile every tick like you do currently. So you can basically stagger off and reconcile, and you can use that for lower end devices. Basically, what that does is it's going to currently the input runs in a reconcile because it's put into place where it should be. Like it's inserted into I guess you can just say the state system to where it should be. So like, let's say if you get the client's always ahead, right? Because they're running stuff locally and you got latency. So the client is always ahead of the server in some degree until they get the information from the server. So let's say the client is ahead 100 milliseconds, right? And at some point while you're ahead, you anticipated that a transform was at vector 3.0, but the server, what happened actually is the server has moved it since then, and your assumption of it being at vector 3.0 is wrong, and it needs to make a correction based on that. So what happens is the state basically, let's say the server state's at 100 and the client in the future is at 110. Let's say the move happened at 102. What happens is you reconcile basically every tick. Let's say the last one you received was 102. you're going to reconcile the 101, and then you're going to run 102, 103, all the way up to 110. Now, by that state being inserted into basically the back end of the past, it's now basically perfectly aligned with the server. So you shouldn't have any desyncs. I mean, you're going to have the initial desync where you guessed wrong, but once it's corrected, it's going to fix that. So that's how it is currently, but in order to do that, you have to actually reconcile every tick, because inputs are run, they're put in the past where they are on the client. So when it rewinds the client to the past or where the server is, it reruns those. And if you don't reconcile every tick, you can't run those inputs, and they're lost. That's obviously bad. So, and there's like eventual consistency and all that, but they're still lost for until that kicks in. So the new approach is, it's going to be an option too. It's not like the actual required approach, but I think it is going to become the default approach because I feel like it's what people tend to look for more. So the new one, and it shouldn't actually be that difficult because it was implemented at one point, is instead of putting the inputs into the past where they belong to get the perfect state replication, they will just instead be run on tick. Basically queued up and run on tick instead of only being run during the reconcile where they're inserted. So instead of being put in the back, they're put in the front where the client future is, and the client just runs them, and they don't have to reconcile to run to get that data because it's up in the future where they are. They don't have to go to the past to run it. So since they don't have to go to the past to run it, you can reconcile less and thus increase your performance and potentially even save a little bandwidth. Well, you probably would save some bandwidth, if you're sending less reconciles. But anyway, you'd save a little bandwidth on the server, and the client would perform better because they don't have to roll back as often. But the downside is you're running those inputs in the incorrect order. They're basically being run, in our example, let's say as the client was on tick 110 and this arrived at 102. So instead of reconciling back and running that, where the states were at 101 and then running 102, where the data was and so on, instead you're running that data on a client tick of 110, and that's not where it belongs. So you're pretty much ensuring that there's going to be a desync of some sort until you roll past that desync and it's corrected and there's no more desync. Is it necessarily going to be an issue for most people? Probably not. I would say, I'm just speculating, but the odds of it actually being a problem is really low. Because one, it's only going to affect inputs you receive. When you sent your inputs, the server knows when you sent your inputs. So the client doesn't really have to worry about mispredicting their own inputs, of course. The exception is let's say you're sending inputs to the server and the client's spiking, and their latency is not great. So end result, the server might run through its queue of inputs because it does have a little buffer that you can configure for this reason. But if that happens, though, the server might run your inputs and not have any inputs to run and just simply run that there's no inputs when there actually were inputs, but it gets them late. That could cause a desync, and the client would correct locally for that. But that doesn't really happen. It can happen. It just doesn't usually. Your internet would have to be on all sorts of bad for that to happen. Now, I know, drops and whatnot, but internet these days is really stable. And the odds of something being so bad that it's actually causing issues like I described is very, very, very low. You'd have to be in unideal playing conditions, and you can't blame the framework for that. It's like if your ISP is doing bad and you lag and teleport into a wall or something, you don't go, crappy game engine code. You go, freaking lag, and then you break your keyboard and your friends have to run away. I don't know if anyone's seen FPS Doug, but yeah. So as I was saying, there's really only so much you can do. You have to basically, in that case. So the odds of it happening for anything you own is pretty low to begin with, and the odds of it happening on stuff you don't own, because you have to get the inputs relayed from the server, it's entirely possible that, it's almost definite that they're going to be out of order, because using this new approach, like I said, it's putting it in the future, not where it belongs, instead of running reconciles and putting where it belongs and whatnot. But the odds of it actually affecting you depends on your game. So let's say you are making a racing game, right? Let's say you have cars driving around the track, and you bump a car or whatever. Now, presumably, car is going to carry velocity, right? So even if something is out of order, the velocity is going to trickle over the frames, or ticks rather, and it's probably going to be really, really, really close to where it actually is anyway, even if you mispredict it. So a mispredict in that case might not even be noticeable. There's also interpolation on graphical objects to help combat that. So even if the interpolation, even if it does cause enough of a desync where it has to be corrected, you might not even see it. I think where you're going to probably see the most desyncs in such a situation is if you are using something like colliders, most likely enter/exit states. So let's say you have an object that's moving towards you that is controlled by the server or another client, and you hit it on your client on tick 110, right? So you fire I've entered this trigger at so-and-so at 110, and you're then going to reconcile out of it, presumably at some point. Now, in reality, let's say you're supposed to hit it at 102, so you might see that you hit it at 110, and that might change how you apply forces differently, or maybe, like I said, it really depends on the game type, so it's really hard to kind of find the perfect example. But what could happen is you could essentially repeatedly make that collision on the incorrect tick, because it's being placed into the future of the queue, not the past where it actually belongs. So if it's placed in the past, what would happen is you would, let's say you did hit it the first time at 110 because of a mispredict or whatever. Once you reconcile, it's going to go back to state 100 or whatever. It's going to see that collision actually happened at 102, not the 110 you thought it did, and your client is going to basically react differently, or physics will react differently to hitting that object at 102 instead of 110, and that will result in a near immediate correction. But again, you'd have to reconcile every single tick for that, and you'd have to run the inputs in the quote-unquote past where they actually belong. So that's the trade-off. It costs more performance because you have to reconcile more, but it's super accurate, super accurate. Whereas if you don't want to reconcile every tick or whatever, you can just drop the inputs into the future and just pray things don't go wrong. Worst case scenario, if you do continue to hit the object at tick 110 when it actually happened at 102, you're like I said, you're just going to keep desynchronizing until you're past that tick. You might not even quote unquote. I mean, I guess you would probably be desynchronizing until you got past that, but um, if you're only reconciling like every 5 ticks, for example, you're gonna reconcile once and hit it again on the wrong tick, and probably reconcile again and hit it on the wrong tick twice. So it might happen twice. Like I said, it just depends on how you want to handle the situation. And I don't know with absolute certainty, but from what I gathered is I believe Fusion does it kind of the second way and putting it in, like putting it quote unquote in the future. Um, and honestly, the only real dilemma where these things happen is usually on enter exit callbacks on colliders. That's the only time I've seen it happen. And guess what? Fusion doesn't support. They don't support enter slash exit colliders in their prediction slash state system. So I'm just kind of guessing. I don't know for sure if that's how it is. I don't look at other networking like code, and so I don't really want to. I don't want to look at it because I don't want to be like, oh, that's brilliant, and then do it that way. I don't want to accidentally take someone's proprietary code. I said accidentally because yeah, I mean obviously if you're like, oh, that's brilliant, I'm gonna do it that way. That's intentionally taking it, but you might be inspired to do it in a similar way, and you know, that's probably completely legal in some sense, but I just don't really like the idea of it personally. But yeah, that's it. I have added the interpolated sync vars. They are done. There's these types built in: float, double, byte, s byte, short, s or short, use short, integers, longs, vector twos, vector threes, vector fours, and vector 2 int and vector 3 int. And you can just make your own if you wanted. This is obviously a more complex one, but it could be as simple as this, just by making your own class. And to implement it, you just do the type sync var equals new rather than this. And basically, it just gives you, it just opens up that feature. And we could probably add other features too as well, or you could even add other features because you now know it's typed. But yeah, technically it's just a custom sync type. It is using some change code, admittedly, new feature code. So I guess it's not just a custom sync type, but they're basically using our custom sync type thing, which anybody can do. So you could do stuff like this with a variety of types in your own code. But anyway, this is done. Been streaming for like an hour 20. I think I'm done. Thanks everybody for watching.